Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. So in today's video lecture, I am going to discuss about the mesh analysis. So here the mesh analysis is the application of the Kirchhoff voltage law. So here Kirchhoff voltage law states that the algebraic sum of the total voltage drop across each and every element is always equal to 0, or we can also say total voltage is equal to the sum of the individual voltage drop across the each and every element. Okay, so here in this today's lecture, so we have to discuss about the introduction about the mesh analysis, what are the steps involved in the mesh analysis, and we will discuss the problems on the mesh analysis. So here in this mesh analysis, let us take, so here I am taking the one circuit here. So here is the circuit. So in this circuit, so I am taking voltage as V, and resistor is R1, and resistor is R2, and resistor is R3, right? So here, so same as KVL here. So step number 1 is, first we have to find out the total number of loops in a given circuit. So in that we are having the two loops here. So loop 1 and loop 2. So two loops means here required currents are 2. So here the required currents are the 2. So here first loop current I am taking as I1 and the second loop current I am taking as I2. So here we are having only two loops. So the required currents are I1 and required currents I1 and I2. Now direction. So here depend on the source, we have to say which loop is in clockwise direction or which loop is in anti-clockwise direction. Okay. So here is the starting from the positive, means the current direction is clockwise in a first loop. So first loop is clockwise direction. Similarly for the second loop also clockwise direction. So here both the loops are in clockwise direction. Now here is the second one. Now the third one. So the third step is we have to assign the polarities across each and every element. So we have to assign the polarities. So the polarities are, so here is the positive. So starting from the positive, we have to start. So at R1 it is plus minus, and at R3 it is plus minus, and at R2 plus minus. Now here, now we can add at R3 also we have to assign the polarity, that is plus and minus. Okay. After that we have to apply the KVL. Then we have to find out the loop currents, that is I1, I2, or power through R1 resistor or R2 resistor or R3 resistor. So this is the procedure for the mesh analysis. Okay. So here we are having some steps involved in the mesh analysis. So in that, so here already we have discussed step number 1 is first we have to find out the total number of loops in a given circuit, and the second step is we have to give the current direction. After that we have to apply the KVL, Kirchhoff voltage law. We have to apply the KVL in a loop 1 and loop 2 or loop 3. After that we have to find out the response of the circuit. So response of the circuit is nothing but loop currents and power through each and every element. So these are the steps involved in the mesh analysis, right? So here I am taking the one problem here. So in this problem we are having the total number of loops are 2. Okay. So here this is loop 1 and this is loop 2. So total 2 loops are there, loop 1 and loop 2. So here step number 1. First we have to find out the total number of loops. So the total number of loops are 2. So here the total required currents are I1 and I2. Now the direction. What about the direction here? So for the first loop, it is a clockwise direction. So this is plus and this is minus. So first loop is clockwise direction and the second loop also it is a clockwise direction. So here the first loop current I am taking as I1 and the second loop current I am taking as I2. Okay. Now here is the first one and the second one is we need to give the current directions. So we need to give the current directions through in each loop. Now the third one, step number 3 is we have to assign the polarities. We have to assign the polarities in a given element. So here we are having the elements 2 ohm, 3 ohm, 4 ohm and 5 ohm. For these 4 resistors we have to assign the polarities. Okay. So here the polarities are depends on the current directions. Okay. So here starting from the positive here. For the positive side, so here this is plus and this is minus, and at 4 ohm plus minus, and at 3 ohm it is also clockwise direction. As per the clockwise direction we have to assign the polarities. So this is plus and this is minus, and here also this is plus and this is minus, and for this 4 ohm also again we need to give the polarities, that is plus and here is the minus. Okay. So for our simplification, so here I am taking loop current, this is I1, and here loop current I am taking as I2. Okay. So now we have to apply the KVL. So the fourth step is we have to apply KVL in loop 1 and loop 2. So here the first loop equation. So for the first loop equation, I am starting from this point. I am starting from here. When I am starting from this point, always we need to take the second polarity. So here the second polarity is plus and the voltage is 5. So plus 5, and at 2 ohm the second polarity is minus. So minus 2I1. Right. So current is I1. So minus 2I1. Now here in this loop, the second polarity is for the first loop, the second polarity is minus and the voltage drop is 4I1. Similarly, at 4 ohm we are having the another second polarity, that is plus. So plus the voltage drop in terms of second loop is 4I2 plus 4I2, and here there is no more elements and this is the ending point, that should be equal to 0. Now simplify the equation. 6I1 minus 4I2 equal to 5. Let us take as equation number 1. So this is the first loop equation, and now we need to apply the KVL in second loop. Now for the second loop, I am starting from here. I am starting from this point. So we have to go for the clockwise direction. Okay. So here I am starting from here. The second polarity is minus. So minus 3I2 for the voltage drop at 3 ohm minus 3I2, and at 5 ohm the voltage drop at 5 ohm is minus 5I2. Next again here starting from this point, the second polarity is minus 4I2. Next at 4 ohm we are having the next polarity, that is second polarity is plus. So in terms of I1 plus 4 I1, that should be equal to 0 because here is the ending point and there is no more elements, that should be equal to 0. Now simplify the equation. So plus 4 I1, so 549 minus 12, so minus 12 I2 equal to 0. Let us take as equation number 2. Now by solving equation 1 and equation 2, we will get I1 value and I2 value. So here I1 value is 1.0714 amperes and I2 value is 0.3571 amperes. These are the loop currents. These two are the loop currents of the given circuit. But in the question, we need to calculate current through 4 ohm resistor. In the given circuit, we need to find out current through 4 ohm resistor. So here the current through 4 ohm resistor is, so here the current through 4 ohm, that should be equal to, so let us take as I1 minus I2, that should be equal to 1.0714 minus 0.3571. So by solving this, we will get 0.7143 amperes. Here is the current through 4 ohm resistor. Similarly, we can calculate power also. So power equation is V into I or I square R or V square divided by R. By solving this equation, we will get the power also. Okay, here is the 2 loops problem. Now I am taking the 3 loops here. So for the 3 loops, how we can simplify the given circuit, right? So in this case also, first we have to find out the total number of loops. So total how many loops are there in the given circuit? First loop, second loop and third loop. Okay. So here I am taking as loop 1, loop 2 and this is loop 3. Total 3 loops are there and the currents are, this is I1 and I am taking current, second loop current I am taking as I2 and third loop current I am taking as I3. Right. Now give the current directions. So at 2 ohm plus minus, at 4 ohm plus minus, at 7 ohm plus minus, and here there is no more elements here. So for the 30 volts already we are having the plus and minus, and for the second loop also assign the polarities plus minus, plus minus, plus minus, and here also plus minus for the second loop. And for the third loop also we have to assign the polarities. So as per the current directions only we have to assign the polarities. So here at 8 ohm plus minus, at 9 ohm plus minus, at 7 ohm again plus minus, and at 5 ohm also plus minus, right? So these are the polarities. So here in this case the 3 loops are in clockwise direction. First loop clockwise direction, second loop clockwise direction, third loop also clockwise direction, right? Now for these 3 loops we need to write the loop equations by applying the KVL. Okay, so here now I am applying the KVL here. So first loop current, so here I am starting from this point. When I am starting from this point, always we need to take the second polarity, that is plus 30. Next at 2 ohm minus 2 I1. Next here at 4 ohm in terms of I1. So first loop current, this is I1, second loop current I2 and the third loop current is I3. So in terms of I1 minus 4 I1 minus 4I1, and here another polarity also is there, plus 4I2, plus 4I2. Similarly, the 7 ohm resistance also is there. So the second polarity is minus 7I1, and here the positive polarity also is there. So plus 7 in terms of I3, 7I3 equal to 0. Here is the first loop equation. Now simplify the equation. So minus 7I1, minus 2I1, minus 9I1, 13I1. So here 13I1 minus 4I2 minus 7I3 equal to 30. Let us take as equation number 1. So here is the first loop equation. Now the second loop equation. Now we have to apply KVL in loop 2. In this case, I am starting from this point. Now when I am starting from this point, always we need to take the second polarity. So the second polarity is minus 3I2. Minus 3I2, and here minus 6I2, minus 6I2, and at 5 ohm the second polarity is 5. So in terms of I2, minus 5I2, next plus polarity also is there. So in terms of I3, plus I3. So plus I3, and again the second polarity, from this point the second polarity is minus. So in terms of I2 is minus 4I2, minus 4I2, and in terms of I1 plus 4I1, that is equal to 0. Okay, so you can see here minus 3I2, minus 6I2, minus 5I2, plus 5I3, minus 4I2, plus 4I1 equal to 0. Now simplify this equation. So plus 4I1 is there. Now I2 terms. So minus 6I2, minus 4I2, minus 10I2, 5, minus 15I2, and minus 18I2. Minus 18I2 plus 5I3 equal to 0. So let us take as equation number 2. So this is the second loop equation. Now we have to apply KVL in loop 3. Now the loop 3 equation. So here the third loop equation. So in this case, here I am starting from this point. So minus 8I3, minus 9I3, minus 7I3, plus 7I1, minus 5I3, plus 5I2, that is equal to 0. Okay, same as equation number 2. Now here also 7I1 plus 5I2, next, so minus 9I3, minus 8I3, minus 17I3, minus 24I3, minus 29I3 equal to 0. This is equation number 3. Now by solving equation 1, equation 2, equation 3, we will get I1 value, I2 value, and I3 value. By solving equation 1, 2, 3, we will get I1, I2, and I3. So here I1 is 3.0837 amperes and I2 is 0.9369 amperes and I3 is 0.9058 amperes. These are the loop currents for the 3-loop circuit. Okay. So in that question, so we need to calculate loop currents. So these are the loop currents and also find power through 3 ohm resistor. So here we are having the 3 ohm here. Now power through 3 ohm equal to current through 3 ohm square into resistor is 3. So current through 3 ohm is nothing but I2. So what is I2 here? 0.9369 whole square into 3. So by solving this equation, we'll get 2.633 watts. Here is the calculation for the 3-loop circuit by using the mesh analysis. Okay. So thank you one and all.